Hello, Professor. Instead of giving you the written form of a talk through, I'm just gonna record me doing one of the problems from chapter 6, and I hope that's okay. So this problem is problem 28, the one with the flea. So the flea, kind of just start writing an example. The flea's gonna be this little dot, and the flea starts on the floor. So the flea jumps into the air, exerting a force down of 1.2 times 10 to the negative 5, 1.20 times 10 to the negative 5 newtons. And there's a wind going this way that gives a force on it of 0.50 times 10 to the negative, I believe this was negative 6 newtons, yep. Negative 6 newtons. And the flea weighs m equals 6.00 times 10, 7 kilograms. Okay, now we have all the givens. Let's figure out what we know. So Newton's third law, every force has an equal and opposite force. So each action has an equal opposite reaction. So we know that this force is exerting down is going to actually propel the flea up in the air with the same force. So this number is also representative of this arrow's force. And also it makes a note in the problem, do not forget about gravity, right? So let's calculate a gravitational force. So our gravitational force will be F equals the mass of the flea, so m here, times acceleration due to the gravity, so we'll just write g. And this comes out to be, I'm going to calculate that on this side, 6.0 e negative 7. We're going to multiply that by 9.8. This is about 5.9 times 10 to the 1, 2, 3, 4, 5, 6 to the 6. And so this force subtracted, so what we're going to do is we're going to take this force right here. So let's just draw a free body diagram real quick. So this is our flea. We'll draw our flea as a box. This is our flea. So we have force going this way, and that's what this force is. And then this gravitational force over here is going to be this little arrow down here, and it's clearly less than. So we know that we're going to have force going upward, and then we have a consistent breeze, and ignoring air resistance, we know that this breeze's force is just going to be the breeze's force. So the best thing for us to do is to combine these two north and south masses into one, so that we have one mass. And we can, create a right triangle where this will be our vertical force and this will be our horizontal force. So when we combine these two, our final vertical force equals, so let's do 1.2 negative 5, subtracting the gravitational force, you get 0. Oh, we'll just call this 6.12 times 10. 1, 2, 3, 4, 5, 6, negative 6. This is newtons. Let's keep our units in order. So this will be representative of this line right here, and then this up here will represent this line right here. So now, to calculate the force that they're asking for, which is this force right here, the combined forces, we want to take both these forces, both these lines squared, and square root them. And when you do that, please hold. I'm going to this answer squared. I'm going to add it to 0.5 to e 6 squared, and we will square root this answer, you get the angular force equals 0.0, oh gosh, why do I keep trying to do this, 6.14 1, 2, 3, 4, 5, 6 times 10 negative 6, and we'll call this 6.14 newtons, right? So this is our angular force. That's not what they're asking. They're asking for the acceleration in this direction. But what we can do is do F equals ma. We know the m, we know the F, so we can do A equals F over little m. When we do that, we get, we're just going to divide this by 6 e negative 7. Get this equals 10.23 meters per second. That's good. And then from here, you are able to figure out this angle, theta, by taking our two previously calculated values and going d, I believe, 5 point. So we want to do TOA, so then this is our opposite. So we want to do inverse tangent of 6.12 to the negative 6 divided by 0.5 to the negative 6. And you're in degrees. You're going to get, oh, well, flip them. Spastic. That's the answer. You're going to get the angle. So this is at an angle of 4.67 degrees. And we're assuming that, you know, we can just say, we don't have to give a direction because we don't have direction specified. We're going to say, you know, from the vertical. And this is your answer. All right. Hopefully this wasn't too long. Thank you.